It. It.
No. Looked like an 80% of my guys. That's good. Yeah.
I gotta get it out of the, just gotta get it out of this. It's still not. Hey,
Yeah.
what's your name?
Me?
Yeah.
Cliff. Not it yet. The meeting host will let you in soon.
How about now?
Negative Ghost Rider. I'm not even inviting you. The
You're not
meeting host will
inviting.
let you in soon. I'm in the wrong meeting.
You're there.
But I'm not there.
Hey, Brian, can you hear me?
Yes, we have audio.
Okay. John, why aren't you in? John, why? Admit, or should I remove you?
I think you just removed me. You're okay.
Lou, do you still want me to accept so you get credit or? You?
Yes. Yes.
Recording
Yeah. Okay, how do I? What do you see?
It's good.
Yeah.
I'll be right back. I gotta put it over it real quick before something just falls.
Good morning, everybody. I'm just checking in with everybody. Can everybody hear me? You're going to have to unmute yourself in order to say yes.
Yes, sir. Loud and clear.
Still coming through there.
Yes, sir.
All right, hang on, guys. We have this guy. There you go. So I can hear it.
Still coming through here.
That's because of this. I know he is. Okay. 1, 2, 3. 1, 2, 3. Can everybody hear me?
Yep.
1, 2, 3.
Yep.
Yeah.
Okay. We're good, right?
Yeah.
All right. John Doe, are you on?
Yeah, I'm on.
What do you see? Can you see everything?
I see, let's see, I've got the participants on the right-hand side and it seems to be blocking. Let me see if I can just get rid of this here. Hang on. Yeah, okay, so I just took out the, yeah, I could see your Econet zoning solution screen. And I can see your preview screen on the left-hand side. So if you go to start the, if you go to play slideshow, you know, from the beginning, it'll probably make that disappear and it'll just go to the slide. Because I can see all of your, yeah, I could see from the beginning. Yeah, exactly. There you go.
I don't want to touch stuff. What do you want me to do? I can turn the microphone.
Really glued to himself.
All right, it's a hot mic now. I gotta find out, what do I do as I'm presenting that people want to jump in, right?
Yeah.
11 participants.
No, you're hot.
John, we're gonna mute you right now.
So I heard you had an event tonight.
It was.
Jeez,
It definitely was.
Okay.
pretty close to you?
No,
Yeah, a mile to the west of my house.
11.
The houses are just destroyed.
Wow.
Here we go.
An hour left on her oxygen tank, and that was last I heard. She's okay.
Yeah, see, it pops up when Chris Libanani wants to be admitted. So,
Hour out.
okay,
No, mine's fine.
what do you want to do?
You got
Oh,
backup
come on.
backup generator.
Michael Bright,
I mean,
can
I have
you
full
make
start
sure
line.
your
Yeah,
mic
that's all I
is muted?
So I got a small place.
Okay.
So I don't need all this. I don't need.
Remember, it's a hot mic. All right. The camera, you can see the camera? Yeah. Yeah, everybody's kind of joining now, John. All right. What do you want to do? Want to get started? It's 1:30.
It's 1:30. We should have started here.
John, you want to jump in front of the camera and I'll introduce you guys. So good morning, everyone. Hopefully everybody can hear me and see John Blankley, who's assisting me, and Brian Saber.
Morning, everyone.
Tech support for P&N and for United Supply. Today's class is going to be on Econet Zoning. And yeah, close that door. We're going to do a little bit of textbook this morning, and then we'll have a live demo with the camera and John and Brian helping out. Can everybody hear me? If you have a question, you've got to come off of mute and kind of sing out.
Lou, did you say you should be able to see you, Brian, and John?
Yeah, you can't see me because I'm out of camera range.
All I can see is the screen, the Econet screen.
So you don't see the camera?
Nope.
You got to stop sharing your presentation to go to this camera.
I see it.
Okay.
It's whatever view they have on their end. They would have to change their view settings, but if you just stop sharing your screen, it'll go to this.
How about that, John? Do you see that now?
Now I can see the camera view, yes.
Okay.
Morning, John.
Good morning, John. How are you?
Brian, come here. I want to introduce you. So I'm Lou, and this is Brian.
Hello.
Hello. Good. No, I'm going to start the presentation now
Okay.
because now I got to share screen. This.
Hey, guys, this is John Blankley. If anybody has any questions during the presentation, please just text it in via the
Chat.
chat here. And either Brian or myself will jump on it and answer your questions.
Okay, so a lot of, can you mute that? Because I'm getting, or, yeah, it's that. Okay. Today's topics, we're going to go over equipment and components, planning, application guide, installation instructions and training, airflow requirements plus excess air, two-stage versus variable speed capacity equipment. We're going to talk about installation. We're also going to talk about managing expectations regarding both overconditioning and bypass and any kind of dumping of excess air. So the first thing I'd like to do, guys, is I'd like to talk about the equipment. And this is the equipment. Only this equipment is allowed to be used with the Econet zoning equipment. So first off, when we look at the air handlers, we have an RHMV air handler, and we recently added an RH2V air handler. Now the RH2V can only be matched with the UA or RA17, the communicating version. And that air handler does have a TXV versus an electronic expansion. So those are the only two air handlers that can be used, right? When you look at gas furnaces, the gas furnaces that are allowed would be the 802V and the 96V. Please keep in mind that those two furnaces are two-stage variable speed. They are not fully modulated. And we're going to get into that and, you know, some limitations with those two furnaces. The modulating furnace would be the 97V, which is the downflow or the horizontal, and then the 98V, which is a dedicated upflow furnace. The outdoor units would be the, hang on for a second, just kind of see if we can put this up here. The outdoor units would be the UA or RA17, the communicating version, and the UA or RA20, which is a fully modulating AC outdoor unit. The heat pumps would be the UA or the RA17. That's the RA17, the P17, the heat pump 20 SEER A and B models. So the 20 SEERs are fully inverted, and the 17 SEERs are a 3-stage heat pump. And all three have the inverter compressor in it. Okay, guys, anytime you want to maybe jump in or ask.
You're doing a banner job right now.
Thank you.
Yes.
All right, so some of the components, we're going to start talking about some of the components that are needed for zoning. First, we have the Econet Smart Thermostat. That's going to act like that is the Zone 1 master controller, and that's going to be the 700 SYS. Okay, and all the other zones are going to be the zone controller. So that's going to be the 700
ZON.
ZON. Okay, we have the Econet Zone Panel. That's going to be the REPNL 700 ZON. And then we have 3 different EWC branded ultra-zone fully modulating dampers. They are the round dampers, the URDs, the slip-ins, the slip-in dampers, and the fully modulating rectangular louver dampers. Okay? They are the only dampers allowed. They also would be the dampers that are used for the bypass as well. Okay? They're not allowed to use any kind of barometric damper bypass or any other manufacturer or a static bypass, or even I think EWC makes their own bypass, smart bypass damper. That's not allowed. I'll get to that model number in a second. The supply air sensors, which are always required, are going to be the RXHT-A02 for the air handlers, and the 4724225-01 for the gas furnaces. Right? The RXHT, that comes with both the return and the return, the supply and the return. The gas furnace one is only the supply because the return is built into the control board.
And you'll notice on the RXHT A02s, there are different Molex plugs for the supply and the return. If you mix them up, you will obviously be reading the wrong temperatures.
There you go. Okay, so another in-depth look at some of the components. On the left, we have the actual zone smart thermostat. That's the master. That's used on zone 1. The Econet Smart Thermostat provides a single interface for users to review the status of each zone. Okay, and then the zone controls, each zone control must be used as the control or sensor for zones 2 through 6. The zone control will display the zone temperature and allow the user to adjust set points, fan speed, schedule, and other settings for that individual zone.
And a key part of the zone thermostat to remember is all zone thermostats come set up as zone 2 from the factory. If you have more than 2 zones, you must go into each thermostat and change it to either zone 3, 4, 5, 6, and name them. Otherwise, you're going to get a communication failure because it's going to see more than one zone 2 thermostat.
Right. Okay. These controls do not have to be home runs back to the Econet Zone Panel. They can be daisy chained to any device on the communication bus. And Mr. John Blankley will be discussing wiring. We've got a, yeah, not yet. No, not yet.
Sorry, I got excited.
Well, we'll be talking more about the wiring as we move forward. When you look at the zone control board, got a couple of things going on here. Upper left-hand corner of the board is the actual connections for E1, E2, R, and C. Please note the connection for RT, Ralph Thomas. That is not used. So we put a piece of tape over it. We don't use it. It's only 4 wires. It's E1, E2, R, and C. When you look at the zone controls for each damper output, we have 3 dampers. They're power open, power closed, and a common. We'll talk more about that as a couple slides move forward. We have the dip switches that are very important. John, you want to talk about those real quick?
Yeah, so when we're using more than 3 zones or 3 zones and a bypass, you're going to need to use these switches for the second panel. It'll switch you to zones 4 through 6. And in the event that you're using a second panel, you are going to have to use the dip switch on there that says bypass.
Okay. And then the unused terminals in the lower left are going to be all of those terminals marked there, RS and RTN, and any of the IAQ terminals. They are not used at this moment. Okay, so when we look at the dampers, the motor is a 35-step zone damper motor. It's a modulating damper. Okay, it's 35 steps. Okay, and it's the same motor is used for all 3 different dampers. If for any reason you need to manually open it, there is a button on the damper motor. Once you push that button, you can manually release the damper motor. Let's just say, for the sake of example, you needed emergency air conditioning, the zone was broke, or something happened, and we needed to open the damper. We can manually open it by releasing the motor and driving that damper open. Okay. Avoid installing the dampers with the motor on the bottom. If condensate or any water falling through that damper motor will be the first one to take a hit. So you want to try to get it on the side. Probably the top is not you won't be able to do it, but at least the side.
Yeah, that's more for the round dampers because
Okay.
we have the rectangulars that can be bottom mounted. So, and if you notice with the round pipe, you're more likely to run moisture right down around to the motor itself and cascade water off into it.
So a question came in.
Yes.
If we can use more than a certain number of dampers, do we use a transformer?
Yes, we will be getting to
We'll
that
be
in a
getting into
second.
more of that later.
Yep. Thank you.
Good question.
Good question.
Good question. Thanks, Randy.
Okay. The supply air sensor, which is required when you're using a bypass, and quite frankly, we'd like to see the supply air sensor in all cases.
Yes.
So the supply air sensor, there's the picture of it right on the left. For the air handlers, like John said, it's a kit, comes with the return and the supply sensors. And for the gas furnace, it's just one sensor in the supply.
The return sensor is baked onto the board already. So we already have the return temperature sensed.
All right, training, planning, and managing expectations. Okay, here's where we kind of get into kind of understanding the theory behind this zoning system. Please understand that this zoning system was developed for fully modulating equipment. So whenever you have the chance, you want to try to use the 98V, the 97V gas furnace, and the fully modulating outdoor unit. They would give you the best opportunity and the best control over the airflow and waiting, admit all. They would give you the best opportunity and the best control over zoning and the zoning capabilities. You can zone 2-stage air conditioning, but clearly you are handicapped by the the capacity of the unit. Okay? Other things to consider, all zones must be able to handle the highest minimum airflow of the system, be it the heating side or the cooling side, one or the other. So if that's really paramount, that's kind of an overarching phrase. All zones must be able to handle the highest minimum airflow of the system, whether that's the heating side or the cooling side. Now, this might mean enlarging the zones or even speccing different equipment. Okay?
You
Comments?
guys, a big thing to remember is I know it says in the instructions you don't have to use a bypass. I would recommend a bypass on every job. Okay, so we don't have to count on over conditioning a space, so we can bypass. Now remember, bypass is not like old style bypass where you're going to have like a 12 or 14-inch bypass. We're talking a bypass that can move enough CFM to hit the minimum airflow required for the smallest zone. That's what we're looking at.
Right. Understand that the theory behind this is protecting the equipment. So if there isn't enough airflow for capacity to start the air conditioning system or the furnace, it's not going to allow the heating or air conditioning to start. So where do we find that other airflow? So we either bypass it or we open up partly or a little bit other zones, and we call that over conditioning other zones. This might lead to uncomfortableness in other areas of the rooms. This might lead to noise. So that's why it's very important to understand the minimum airflow requirements for all of these systems so that you can best pick the equipment needed. Okay?
Perfect.
Would you agree with all that?
Absolutely, that was very well stated.
Okay, so some things to consider before it's installed. I mean, clearly after it's installed, some of this stuff can't be considered, but before it's installed, what are the things that we want to consider? We want to consider the system's minimum and airflow requirements, minimum and maximum airflow requirements. We want to find out how many zones and panels are needed. You can piggyback 2 panels. We'll show you how that's done. Can each zone independently support the system's minimum requirements, and is a bypass needed? Is a transformer required, and how many zone boards and dampers are needed? Okay? Do I need a supply air sensor? We
Yes.
can all say yes to that. We're gonna look to see a supply air sensor. Group rooms that have similar usage, occupancy, and heat loads. Different levels, stories should always be in separate zones. For better energy savings, separate those areas which will be unoccupied at different times to allow setbacks as needed. And for more precise comfort, separate areas with different heat loss gains as well as different levels. Now, what does that kind of mean? So that means that if you have, say, a mother-in-law suite at a house and you're zoning it, and she wants the mother-in-law or that area needs to be having a greater heat value, that might offer some challenges because you have to heat that, and if that doesn't meet the minimums, then you've got to bypass that heat somewhere else. You've got to put it somewhere else. All right? Intelligent bypass. When used, the bypass damper will be another motorized damper, not a spring or a barometric type damper. The bypass opens at system startup for 60 seconds to provide a soft start. Do not attempt to use any kind of barometric damper or even the EWC smart bypass damper. And really, the last bullet point there, and really it should be the first one, is try to limit your bypass to no more than 10%. Just like John was saying, when you go to bypass stuff, it's no longer that 14-inch round or 16-inch round where we're dumping huge amounts of air back down into the return. The bypass needs to be limited to no more than 10%.
Yeah, it could be a 6-inch or an 8-inch. I think 8-inch is probably the largest we've used for a bypass.
Okay.
Because you have to remember, it's not the same as a duct where you're trying to get your CFM through a duct. An 8-inch duct we know can move 240 CFM. But because you're coming off of the supply and feeding right back into the return, that's increased now. So it's not just 240 CFM anymore.
Okay. Okay, so here's where we're looking at doubling up the boards. So here you see a picture on the left. You've got two boards. Clearly, the upper board is going to be zones 1, 2, and 3. And the bottom board is going to be zones 4, 5, and 6. Now, if I need a bypass, and I'm doing 2 zones, I'm only going to use one board. That's the top board. And zone 3 is now the bypass. And you have to set that up with the Econet thermostat. You have to tell it that zone 3 is the bypass. Now, if you're doing a 5 zone system and the 6th zone is a bypass, you won't be able to tell it through the Econet that has the bypass. You need to use the dip switch, as John noted, flipping it over to the bypass. Okay? Does that make sense, guys? I'm going to kind of pause there for a second. Anybody's got any questions? You've got to unmute yourself to ask the question or type it in chat. Okay? Cool. All right. Picture on the right shows the plastic housing. You can move that up, mount your second board on. I've got the star here, and the reason why I've got the Macy's symboled star is because when you look at the damper motor, going from left to right, you have common, power open, power closed. But then when you look at the control board, they're not in the same order. So we've seen issues where guys just go, one terminal to one terminal, second terminal, third terminal to third terminal, without looking at the terminal designations. So COM goes to the COM, PO goes to PO, PC goes to PC. Okay? And then you could have up to 5 dampers. And once you go past that, then you're going to need a transformer.
What is the maximum number of dampers you could put on a zone panel?
You can put up to 30.
Zone
Five,
panel.
one zone
panel?
No, one zone panel, 15.
15, so that's 5, 5, and 5.
Yeah. 5,
Right.
5, and 5.
Thank you, Brian, for that.
Good questions, Brian.
Very good.
Somebody's got to ask questions.
So there's another question I see in the chat.
Can you buy the panel casing as a separate part, or it comes with the plastic? So each board comes with its own plastic casing. If you need 2 boards, you just pull one out of a plastic casing, slide the one board up in its plastic casing, and then you'll have an extra plastic casing that you won't need.
What you see on the right is the way it comes. If you need a second board, unfortunately, you just have to buy another casing and just remove that second board and mount it in the casing. Okay? Does that answer your question? There's another question in the chat. Sure?
Yep.
Okay,
I just said roger that.
Oh, okay. Cool. Let's see. Okay, so now we're going to get into wiring. So let's talk about the wiring. So I'm going to show you this. I'm going to kind of describe this a little bit, and then we're going to stop sharing the screen, and we're going to move the camera over to Mr. John Blankley, and he's going to show you a hand-drawn diagram that we can work with. So what you have here is you have a 2-zone system, and if I needed a bypass, zone 3 would be the bypass. And it's set up via the Econet smart thermostat, not the dip switch. Zone 1 is the master thermostat, and zone 2 would be the Econet zone control. Okay? So what I'm going to do now is stop sharing. All right. Can everybody see?
Yes.
All right, guys, what I want to start with here, I want to talk about the wiring and how it works and why we have to do it the way we have to do it. Okay? I equate this to a bus line. Okay, so you have a bus that starts over here and it's going to have stops along the way. Okay, where it's going to drop off and pick up. In this case, information. Drop off information, pick up information. So what happens is bus leaves, stop one, drops off, picks up. Next stop, drops off, picks up. As it's doing this, things are going to happen with the system. The system is going to start to react to the information being sent out and returned via the bus. Okay, so we need to be in series, daisy chained together. So if you look up here, we come from our main thermostat here down into our furnace. From our furnace, we come out to zone stat, okay, which is zone 2. From there, we drop down to our Econet control panel. And then from the control panel, we go to our outdoor unit. So now we're in series. Now, what I've run up against when I go out into the field is I find guys tend to bring all the wires to one point, wire them together, and stick them under one terminal. Now, the problem with that is we're not going to get the communication that we want from the system. So what will happen is the bus will come out, it's going to go up here, it's going to stop and drop off and pick up information. Now, when it comes back down to this point, I'll kind of give you an idea here. So here's the terminal, and here are all of our, this can be a stat, furnace, outdoor unit, and zone 2. Zone panel. What about this?
Zone stat.
Zone stat. So the bus leaves, it goes up here, drops off, picks up, comes back down. Now where's it going to go? So it can go up here, it can go up here, or it can go up here or here. The problem is when it comes back down, it's going to be like, all right, now where am I going to go? I'll go out here, or I can go back here again. Okay, so we're not getting a nice, steady stream of information all the way down the bus. So this is no, cannot have that. We're not going to get the information we need back to every part of the system that is required to operate during a call. So does everybody understand what I'm talking about there? Any questions?
Got to unmute yourself in order to ask the question,
Or type them in the chat.
or type them in the chat.
Either or. Okay, so
Randy Winkler wants to know, where does the supply sensor tie into in the RHMV? It ties into the, excuse me, it ties into the control board.
yeah, there are 2 terminals. One is a 2-prong Molex and the other one's a 3-prong Molex. Right on the board. They are labeled, I believe, SAT and RAT on the board.
Michael Bright, if you wanted to just stop your cameras on, so just make sure your cameras. There you go.
Okay, any other questions about that? Okay, so now, some of the questions we have are how many wires do I have to run to each stack or each component? That depends on how many zones you have, because we have to make sure that we're in a series bus, okay, daisy chained together. We have to make sure we have enough to go out and come back. Now, what I tell my contractors is to at least run a 6-wire to a thermostat. Not all the thermostats, but you need at least 1 or 2 of the thermostats, or even the outdoor unit, to have an additional set of wires to return back in with my communication. We're not worried about RNC. RNC are just our power in this case. Okay, so we're going to get the information back as long as we have E1 and E2 going out to a component and coming back from a component to another component. That's the key to the communication. Okay, so when you have somebody who says, I only have 2 wire, can I add a transformer? No, you cannot add a transformer to an outdoor unit, okay, for a communicating unit. Can we use this system with non-communicating outdoor units? Yes, we can. We prefer that you use the staged equipment, the two-staged equipment, or the variable speed, the inverters. But yes, you can use single-stage equipment. I'm not going to tell you can't. Does it work? Yes, it works. Okay, matter of fact, most of the systems that I've helped start up are the ones that have single-stage outdoor units.
But it has to be set up correctly.
Yes, you have to go through the setup. You have to make sure you have the right amount of airflow. And the system will protect itself against freezing coils or over temperature on the limit. Okay, this is a big reason we need the supply air sensor, because the control in the thermostat, in the main thermostat, will allow you to limit the temperature leaving the furnace, okay, before you're going to trip the main limit in the furnace.
It's preset at like
Preset
160.
160, yes. And you can change that. So that can be changed, but 160 seems to be the number. So one of the things that I get a question of a lot is with the furnaces, they'll see that the limit is rated for 115 degrees. Thank you, Brownie, that was a very good point. So 115 degrees. Now you have to remember that 115 degrees you see, I have guys wanting to put in 185 degree limit. It's that temperature plus your maximum temperature rise, which will put us at about 185 with that. So that's why our 160 preset in our thermostat is perfect for what we're doing.
Gives us a little bit of cushion.
Gives us some play. So when the bypass opens and we're dumping hot air back to the furnace, okay, we're not going to trip the furnace off on its limit. Okay, we're also protected against freezing. Okay, so the system is designed to protect. Does anybody have any questions about that?
Okay.
Okay.
We want to finish the slideshow?
Yeah.
Okay. 9 o'clock. We got plenty of time.
Yeah.
Okay, share screen. That one. Okay. All right, so we're going to keep going. So that was John's explanation of how to wire it. Econet zone control board wiring. The bypass in most cases will be wired to zone, if it's a four, oh yeah. There we go. Sorry about that. Good.
Good.
All right. So in a 4-5 zone system, the bypass is going to be wired to zone 6 and configured via the dip switches. But for only a 2-zone application, the bypass is used on the first board, and it's now controlled through the master thermostat. You set it up through that. Now the thermostat has to have firmware 26 or later. So when you go into the Econet thermostat in service, you will see all of the software versions of all of the different equipment. It's the last 2 numbers that is the software version. So anything past 26 will have the capability of setting up the Econet bypass via the thermostat. Okay. Gentleman earlier asked about a transformer. A second transformer must be installed when there's more than 5 dampers or if I'm using 2 boards. Now, how do I install the transformer? So it is a transformer, it's a 40 VA transformer. John, is that locally purchased or
Yes.
is that
Local
It's just-
purchase,
just
yeah,
buy
can use
any-
one that
Sold separately.
just comes out of a
or
furnace.
sold separate? Batteries,
separately, yeah.
batteries not included.
Yeah, please make sure it's fused.
Okay,
Yes.
it's fused and that it's connected correctly. How do I connect the transformer correctly, he asks.
Good question.
Good question. You wanna,
Okay, so what you have to do here, if you notice the wiring diagram, you will see the top board does not have 24 volt power coming from the furnace. it drops down to the lower board and picks up the power from the transformer along with the common. So we can share the commons, but the 24-volt feed is only coming from the transformer for the boards now. So now that's the power source that's going to be powering the dampers coming off of that board,
Right.
of each board. So now you have to make sure that we are not bucking transformers. Okay, so what you have to do, the secondary transformer, what you're going to do is you measure between the red from the furnace and the red from the secondary transformer. If your voltage is 48, you're out of phase. You have to switch the wires on the secondary transformer and then check the voltage again. Should be very close to 0 when you're in phase.
Okay. There's a chat question. I see a number up there. Chat. So I remember reading that the master thermostat is for zone 1. So if we use a bypass, what happens then? Well, Randy, really, I need to ask another question in regards to this. How many zones is this system? If it's only a 2-zone system, it's a 3-zone system. So zones 1, 2, and 3 are going to be on the first board.
Yes.
Okay, and then the bypass is going to be on zone 6 of the second board. It's not going to be on zone 4. It's going to be on zone 6 of the second board. A transformer is needed, okay? And the dip switch on the second board needs to be set up.
Oh, well, no, there's 4 or 5.
Right.
zones, yeah, so-
So the dip switch, the second dip switch on the second board needs to be set up to bypass,
I think you
Still have to hit the zone 4 to 6 switch.
right?
Both switches.
Okay?
Right, to tell,
Hit both switches. So
Right.
it knows that there's another board in the system.
That's
It's not
correct.
looking at 2 boards as the same board. You will get a communication error there.
is that, Randy, does that help your answer your question? Yes, thank you. All right, cool. All right, so like John explained, the picture on the right shows the furnace without the R from the transformer going into the furnace. The furnace transformer is powering up the Econet and the outdoor units, or the outdoor unit. And then the secondary transformer is powering up the boards and the dampers.
Yes.
Okay? Okay, here's a picture of what we were just talking about with 2 boards. Okay, and there's your dip switch settings. So with Randy and your question, so the second board, dip switch 1 would be moved over to the on position, and dip switch 2 would be moved over to the on position as well, because zone 6 would now be considered a bypass.
Can you just touch on why the red wire is not connected from the Econet 4-wire bus?
Yes.
I'm
That's
sorry, did I jam you up?
that's because we don't want, that's the bucking transformers,
Correct.
right? We don't want the transformer from the Econet bus and the furnace side tying into the transformer, the secondary transformer. Is that a good
Right, I
answer?
just wanted to point out that the red wire
Is
from the
not.
system is not connected
Correct.
to the boards where the red wire from the secondary transformer is.
Okay. And then here is a picture really of, a 6-zone system. 1, 2, 3, 4, 5 plus 6. 6, I had to count that out. 6-zone system. Right? With the secondary transformer and with the equipment. I'm going to kind of stop there and ask if there's any questions, either put them in the chat or open up the mic.
But guys, you'll notice up the top there, the zone 1 step coming down to the board. You'll see it looks like it's just bypassing the board, but it's not. When you can wire nut the wires together right there that are going into the board, you can fit 2 wires comfortably under each screw on either the furnace, the outdoor unit, or the zone panel. So, but in this case, they're just showing it that the wire's coming past. There is a connection point right there. And that is fine to do. That is in series, that is not parallel.
Okay. All right, so now we're done. We're done the wiring, we're done the planning and the installation. We're going to talk about, before we talk about startup and commissioning, I want to try to explain some of these minimum airflow tables. Okay? Some of this we'll have to wait until we get down the road, down a few slides, so that we can kind of better understand it. But as you can see, we have two tables here, and there's more than this. There's other tables as well. But these are the tables that are baked into the Econet system to look for the airflows. Okay? Now we're going to pick two pieces of equipment.
Excuse me.
Yeah, go ahead.
Hey, guys, real quick, if you want to get the service manual for the zoning.
Yeah.
Okay, we sell them here at the distributors. I think most of the distributors do. Okay, so very, very important information. Okay, to have.
Oh,
This does have the airflow tables
Right.
in the backs of the book. Okay, so very, very important tool.
Yeah.
It's more than just a service manual. It is a tool for you. So you know when you're selling equipment, what you're really going to need.
What?
You stole my book.
I know. I'll give it back.
QR codes, John?
Does it have QR codes?
Because that would be nice.
They should be in the back.
Are they?
Because that would be awesome. Like the other.
I don't
That's
think
probably
we-
the other book.
Oh,
I don't think we've done QR codes for the
they're
zone.
great.
I know.
They're really
No.
good.
Well, take that as
How old is this book, Greg?
It's old.
I'm gonna go grab one of
Let me
those.
grab the one out of your office, John.
I'm gonna grab
No, John's going to leave and get one. Okay. All right. So while John's ducking out here for a quick smoke, we're going to talk about these airflow tables. Okay. So I'm picking a unit here, and I might have picked some wrong equipment for people, but that's okay because we're trying to use this as an example. So here we have an RP or a UP 2048B. So this is a 4-ton, fully modulating heat pump, 20-SEER heat pump. Okay. And we have 550 for low cool, and we have either 600 or 950 for low heat. And why is there a number 2 associated with that? So when you look at note 2, it says when the smart thermostat version 26 or later is used and the system is zoned, low heat minimum changes to 600 CFM. Okay, so a lot of this is dependent on the software that's installed in the Econet and some of the minimum and maximum tables that are baked into this. Okay.
There are no QR codes in the zoning solution book, but I can show you what we're talking about with some of the training manuals we have here. We have
They can't see that. I can
we have an
stop sharing.
R96V.
You stop sharing your
Stop
screen.
sharing?
and we'll go to
Sharing
this
screen.
camera. Okay, we're good.
Okay, you'll see we have an R96V service book here. Okay, this is a service manual. We have these for most of our equipment, 97s, 98s, air conditioners, heat pumps, things like that. Guys, definitely worth the purchase, especially if you have a lot of techs in the field. I sound like a salesman now, but this is really important, okay? It helps us because in the backs of these books for these servicing units, we have QR codes in the back of the book that will actually help your guys in the field when they're trying to troubleshoot and they can't get a hold of one of us, i.e. Brian or myself, okay? But it walks you through different things like testing pressure switches, main air limits, just kind of walks you through, and it helps the tech, experienced or not experienced, walk through watching a video how to test this stuff out of the eye shot of the homeowner. So we get to look like we have very intelligent guys in the field who may just be out there for a short period of time. And it's going to help them gain experience and gain confidence when they're servicing units. Yep. Thank you.
Here, I want to show the Econet solutions or the zoning solution.
Here's the zoning solutions book. Okay. As I said, it kind of goes through everything for you. Walks you through exactly how to start up the system. We are going to go over that today. Okay, that's one of the reasons we're having the training here at PNN, because we were able to get the unit and the bypass and the zones. And we have an inverter here along with the 96V. So it allows us to actually field or train in-house and let the guys play with it before they get out into the field. Okay.
A couple other items of note. We talked about application and design. So these are found on my REAM or my RUD portal under zoning. And these are good reference guides to have when you're setting up or, planning and speccing a job. It just kind of runs through the glossary of terms, what to look for. It has in the back the minimum and maximum tables. And it also just kind of walks you through some pitfalls that you may need to be aware of with like existing home ductwork.
Yes. And for the DSCs who are in here, I know Brian and myself do it. Okay. We actually kind of hold the hands of the contractors. I mean, here we only have two people who will work with the contractors, myself and our one buyer. Okay. Because we know what equipment goes with everything. And it's important to know your matchup so we don't have things happen like guys calling into the branch and saying, hey, I need a bypass, barometric's fine, or whatever, damper, I don't care. But the important thing is that we get the right equipment out there the first time. Okay, so very important, and we've done very well here. We've probably sold 30 or 40 of these now. Okay, since it's come out, I've been out on probably a dozen for startup. Okay. It really helps the contractor gain confidence when they can either have you there or come to a training facility that has it where they can actually walk through it before they get onto a job.
Okay.
Okay.
We're good.
Thank you.
Oh, I got to share my screen. Okay. Okay, so now we're back to these minimum airflow tables. So we looked at the 48. Now we're going to look at an R96V 085. We picked an R96V 085. It's a very popular furnace. It's not the best for this particular application, but let's go with this and we can see where we can pick even a better furnace for this application. Okay, so when you look at these numbers, these airflow numbers, 1300, 1065, and 925, they correspond to if you had a standalone furnace and you were setting this up via the dip switches, those dip switches you would set them up either low, lowest, or standard 13 mid-rise across the airflow across the furnace. So the lowest airflow that this furnace could handle would be 925 CFM. So if this combination, the 4-ton outdoor unit with the 96V was installed, your zoning system needs to handle 925 CFM for the smallest zone. Okay, that's what we're talking about, guys. All right.
Guys, I have to harp for a second here. I get a lot of phone calls from guys who end up putting an 85 or 100,000 BTU furnace in with 3-ton or less of air. I'm telling you right now, you've got to wake your contractors up. Okay, and if your contractors are out there listening to this, we have to wake up to the fact that most furnaces are grossly oversized.
Yep.
Okay, so in this case, if we were going with a 3-ton system and we matched it with the proper furnace, our minimum airflow required is going to be much less now. Okay, so when we're looking at this matchup, yes, it's a 4-ton with an 85 furnace. It's a great matchup. Okay, I'd rather see the 98 or the 97 with it.
Right.
Because we have much better control of our minimum airflows with respect to the inverter.
Correct.
Okay, so we can drop that way down. Okay, but in this case, we have to make sure that our contractors understand that oversizing of furnaces just harms us when we're trying to get our airflows down where we really need them to be for the smaller zones.
Yeah, we're gonna talk about, Randy, we're gonna talk about the mod furnace versus the 96 in just a sec. Okay? So now when we look, we keep going with this. Okay, so here are our two, our systems, right? Y2 numbers in the heat pump heating mode by note 2. I think we already talked about that because the note suggests that if we have version 26 or later, we can use the lower of the CFM. There's your 600, okay? Now, if I was matched with an RHMV for this 4-ton, my two numbers would be 600 or 550, okay? And the highest of those would be 600. So my smallest zone needs to handle 600 CFM. What happens if we try to move only 600 CFM in a gas heat mode? If it actually did it, the limit switch would certainly trip, but the unit will not run without assistance. And the word assistance is a little misleading. What do I mean by assistance? I mean to say that I have to find another 325 CFM. So I have to put 325 CFM somewhere, okay? Where is that 325 going? Is it going into a bypass? Is it going into another zone? So I have to move or open another zone or the bypass to move that to meet the minimum airflow requirement for the equipment to actually start running.
And remember, if it is the bypass that's being called first, there's a chance you can over temp or overcool that unit.
Right.
So you have to make sure that we're in the right zone and we have the right system in there once again.
Okay, how and where do I set these airflows? 925 CFM is the lowest amount of CFM this gas furnace will allow on first stage. Okay,
So we had a question come in.
yep,
Is the minimum airflow the smallest zone plus the bypass?
no,
No, it is not.
no.
No.
It's the equipment's
The lowest fan speed that.
for that
unit
equipment
can
selection, correct. So whatever equipment you've selected, it's the lowest CFM, whether it's heating or cooling, that equipment can drop down to start the equipment. All of this is based off of the equipment, guys. So if you have, I'm just picking a 2-ton RA17, not a 2-ton, a 3-ton, a 3-ton RA17. So the RA17 36 has a 2-step scroll in it. It's about 67% capacity on first stage and 100% capacity on second stage, okay? So what's 67% of
2-ton.
2-ton? So I have to move 800 CFM on first stage of an air conditioning system, okay? That's the reason why we're protecting the equipment, okay? Hope that answers his question.
Anthony, did that make sense to you?
Good.
All right, thanks.
Okay. Where do we put the additional 325? We can bypass it like John and I have been talking about. But again, what happens if I send it back to the return? Now I have, it may be okay, or it may trip the auxiliary limit or set an alert. Okay. Now here's really where you get the homeowner's input on all this. The homeowner keeps getting these alerts, lower cutbacks, limits tripping, the unit's not running right. I've got issues with this zoning system that I spent a lot of money for, okay? It's either not set up right or the equipment is challenged because it's not really the right equipment for this application, okay? So that's why we have to do our homework prior to setting the equipment. Is there a chat question?
I can see.
Okay. All right, what happens if I send this 325 to another area of the home? May be okay, it may be over conditioning, and it may be uncomfortable for the homeowner. What happens if I don't send the air anywhere? Static will rise towards the airflow, I will exceed airflow limits, and I'll surely hit lower cutback. Because quite frankly, in the settings, I can allow the system to go to unlimited, correct?
Yes.
And that says, look, I have a 6-inch round, but I'll put 1200 CFM down that if I want, okay? So that's what unlimited means. The problem is, just like it says, statics rise, I'll get noisy airflow, I'll exceed airflow limits, and I'll get blower cutback. What is blower cutback? Brian asks.
What is blower cutback?
I'm glad you asked that question.
Thank you.
It's when the blower motor reaches maximum RPM and there's still a demand for more airflow. Blower cutback shuts the system down because we can't move enough air. You know, in the immortal words of, what is it, Scotty from Star Trek or Star Wars? She's given it all she's got, Captain, but
Can only get 3 warp out of her.
I can only get 3 warp out of it. Okay?
Good
Would there-
question, Brian.
Yeah, thank you for that question.
Yeah, no problem.
Would there be a better choice of equipment? Absolutely. And in this particular case, we move to what John Blank was saying. Yeah, we could pick an R98V, which has a more lower maximum lowest CFM number of 730 versus 925. Okay,
And you'll see there's 2 different numbers listed up there.
Yes.
We have comfort mode and efficiency mode.
what is that about?
What comfort mode does, that slows your blower down, okay, gives you a warmer temperature rise on your furnace.
Okay,
Okay, I normally set these in efficiency mode because I want it to lower the air. A lot of the times you'll have someone who's older who will feel the drafts a little bit more than someone younger. Okay, and they want that air to be warmer. So that's where the comfort mode comes in. Now remember, you know, depending on your ductwork, you could be more likely to trip a limit on a furnace, even without zoning. So in this case, with zoning, we do have the protection in there for the bypass, but not for the zone itself. So that will be the limit in the furnace itself that will trip.
Check your chat. I'm not seeing them, but you got them coming on your side.
yeah, that's because it. So now it'll go away because I opened that up. All right, there you go.
Yeah.
Okay.
I think you had questions in there. I saw a question in there that we didn't ask.
Is there any way to tell without wiring up the T-stat?
If you get the box from your supplier, on the bottom of the box, it's going to have SW, and then it's going to have the software version on the bottom of the box. In this case, right now, we have the 0.39, so you'll see that on the bottom of the box. If it was an older version, you see a 2.6, okay, but it is on the box.
Randy, does that help answer your question?
That's right. You see it, right?
From Jared to everyone. U98
Yeah, there's a sticker.
V060 with a 1736 coil. Okay, so Jared, I saw the equipment selection there. What is your question?
Jared, that's probably something we want to take offline, and we'll deal with that after this meeting, because that's a pretty specific question for your one
Yeah.
system.
Yeah.
Yeah. 6x8.
Okay. Yeah, Jared, we can answer that.
I see what he's saying there. He's just asking what the minimum airflow is for that furnace.
So for that, was it 60?
196 VA 60.
Go back a slide or two to
60.
that chart.
First stage would be 525 and 788. Is that a 2-ton?
There you go. That one. And then we can.
98060 would be 550, and then the 1736 would be 675. So 675 would be the highest of the two, right? So that's if it's mod furnace with 2-stage
Legacy
legacy.
outdoor thermostat.
Yeah, that's not, that wouldn't be the right.
420,
550.
6x8 ducts, usually a problem.
6x8 duct is a problem.
Yeah.
Especially when you put the damper in it.
So. I mean,
14 by 8 and the zone 2 is 6 by 8. What's a 6 by 8 move? 100 CFM?
I don't know, I don't.
Hang on, I'll tell you.
550 into zone 2, only 6 by 8 seems like a problem. That would be correct. That would be
I
correct.
have a dumbler on me.
So guys, this is, so as Jared is showing, I mean, it's kind of good that we're answering this question right here live. This is one of the things that we need to figure out even before the system goes in.
So that's about 250
Yeah, somewhere
CFM.
around the 250 mark is what you're gonna get out of that 6x8 duct. So
Right.
anything above that to meet your minimum need would need to go into either the bypass damper, which is limited to 10%. So
Yeah.
if
Jared,
you're over
does this
that-
have a bypass? You can come off mute if you want, just kind of talk to us. Talk to me.
No bypass.
No
No
bypass on
bypass.
the
Okay, so
side.
you're gonna be
dumping into
a
the
lot
other
of
zone.
air into
Into
another
zone 1. Yeah, so if zone 2 calls, you're gonna be dumping it into zone 1.
Unless it's locked out,
Yeah. the system
where it's
may
not
even
allowing
start at zone 2,
overcool,
it's
depending
still
on how it was set up.
Right, we'll get into that. Jared, we can talk about this afterward, but this is a classic example of what we see. And really what ends up happening, guys, I'm kind of going off the cuff here, but what ends up happening is the homeowner gets fed up with it and says,
Rip
you
it
know,
out.
rip it out. So it's a classic example of how it was installed and not set up correctly, and this is a result of it. So thank you for sharing.
Yeah, that's a good point right there.
Yep.
That shows exactly what we're talking about
Yep.
here about design.
Okay. Jared, we can talk later offline about this. All right, cool. Where were we? Was there another?
He said he upside zone 2 to 10x8.
I don't even know. I have no idea whether that's even right either.
that?
What was the minimum? I don't. I mean,
550
550 on
or 675 with the heat pump.
10x8 is probably a little light, but your static will be a little higher. It's a lot better than the 6x8, that's for
Yeah,
sure.
really. Okay, so let's keep moving on here. Let's talk about, let's kind of have a pictorial here of, you see my screen? I'm good?
Yes. Yeah, we still see that.
Pictorial here of the return, the supply, the furnace, and the coil, horizontal. So this would be horizontal right, supplies on the right, returns on the left, okay, with the bypass. And I think one of the things that we want to take note of is how the bypass is dumping immediately right back into the backside of the furnace.
Yeah, you want to try and go as far down the
Farthest
return
forward.
duct as you can with that to allow more of a mix with the tempered air coming back.
Right,
That'll help us,
right.
alleviate any limit trips.
Show pointer options. Laser pointer. So this bypass should be really down here. Okay, and what that does, like John said, is that'll give that hot or cold air a chance to commingle with the other return, and it won't be dumping hot air or cold air directly back into the return of the furnace. Right?
Perfect.
What could go wrong here? Short cycle in the furnace or AC due to very hot or cold air being dumped directly back into the furnace. How much can we bypass? We talked about this. So recommendation is for no more than 10%. Okay. What if I try to use a different type of bypass? Well, the only bypass approved is the EWC brand Ultra Zone fully modulating damper. Again, it's one of the dampers that you use. It's not a special damper. It's just one of the other dampers.
Powered 3-wire modulating damper. And part of the reason is, okay, during your startup, your commissioning of the zoning, if you have a barometric damper or a static driven damper, it will open and it will throw a fault that will make it look like you have air escaping before the dampers,
Looks like duct leakage,
duct leakage.
okay?
Okay, so that's the big reason, because these are positive shut-off dampers. They are sealed. You don't get air out of them or through them. So we have to make sure that we're using the right dampers for this application.
Okay, what is overconditioning? Overconditioning is used when a zone that's too small calls and requires excess air to go somewhere else. In this case, it's either in another zone or multiple zones. You could have multiple zones it's dumping into, okay? What's the yellow brick road? Is it the overconditioning first or is it the bypass first?
It's going to be the bypass first until we hit our limit.
Okay,
Okay, in this case, the temperature. So as it starts to get to the temperature where it's going to start to close the bypass off, then you're going to see your other zones open up. Okay, you're going to see the zone furthest away from set point, right?
yeah, I'll show that here in a graph.
Yeah, the next slide, I believe.
Okay, yep.
Slide right there.
Where do I select this setting? Each zone has its own overconditioning setting. It's done in the settings screen on each zone control. And when John and Brian do the setup here, you'll see that and you'll see how it's set up. What are my choices for settings? You can none, you can auto default 1 to 10 degrees, and I can explain the difference in the different settings. So none is no overconditioning will be allowed. So that means to say that we'll go back to that example where it was 325 CFM, okay? So if I have 3 zones and I put all those other 2 zones, the master and the other 2 zones to no overconditioning, there's no place for that extra 325 CFM to go. So you probably don't want to pick none. Auto means this setting will allow overconditioning to occur in setback zones only. Define setback. They can only be overconditioned to the most conditioned space, and they will shut dampers once that temperature has been reached. With setback zones, the one farthest away from the calling zone will be used first. If there are multiple setback zones and all are set back equally, they will all be used equally. Okay? And 1 to 10 degrees, when a zone is set to a temperature setting of 1 to 10 degrees, that zone can be used to accept excess air up to the overconditioned setting in that degree above or below its set point.
Don't recommend that.
Okay?
Extreme, 1 to 2 degrees for each zone.
Right.
Normally, you're going to condition the space that is calling in that time period. So we're not talking about this thing running for hours and hours and dumping excess air. We're talking about probably a short run time, maybe 15, 20 minutes.
Right. And understand this, guys, this is another reason for these modulating dampers, okay? So 325 CFM is not a lot of air. That damper's not going to be wide open. That damper might drive open a quarter of the way just to at least alleviate or allow the 325 to go into that zone and disperse itself into that zone, all right?
I've seen them barely crack open.
Right.
Yeah.
Just to get you to that minimum airflow requirement.
That's correct. And here's the example. Zone 1 is the only zone calling for heat, but it cannot run by itself. Why? Because zone 1 airflow does not meet the minimum airflow requirements. Zone 3 will be the first zone to open to help zone 1. Why? That's because zone 3 is the farthest away from set point. Zone 2 will open when zone 3 is equal to provided it's set to over, provided zone 2 is set to overcondition and there's still a call for heat. So if you look at the the red and the black lines there, when I click, what ends up happening is, as the temperature rises in the space, zone 1 is satisfied, zone 3 came up from 68 to 69 degrees. And that's because we use zone 3 to dump air, excess air, to provide zone 1 cooling. Okay? Work?
Beautiful slide.
Cool. All right, so key takeaways. Size each zone so it can handle the higher of heat or cool minimum. If you must bypass, limit the bypass to 10%. If you must overcondition, take responsibility for the discomfort in other zones and when those zones become an issue. And if you can't enlarge the zones, use equipment with lower minimum airflows. Okay? All right, so what I'm going to do now, guys, is I'm going to stop sharing. And then what we're going to do is we're going to kind of open it up to you guys to have questions. Okay, we're going to take 5 or 10 minutes to ask a couple of questions. And then we're going to go through the setup of an Econet zoning system. How to set the thermostat up. It's going to be hands-on. We're going to show you how the dampers open and close. We're going to show you all of that stuff. Questions? You can open up your mics now and speak freely or chat.
Crickets.
I'll take a 5-minute break.
Yeah, take a
Let's take a
5-minute
5-minute
break,
break.
you guys, and then we'll jump
5, 10
over to
Okay.
the.
We're going to take a 5-minute break. I'll leave it all open here.
Get Brandon up
Um,
there.
I will turn off the mic just in case someone accidentally says something inappropriate. And we'll reconvene in 5 minutes or so. Thank you.
I've heard some
Yeah,
Yeah, that's always good.
No donut fights in my training room.
okay, we have a hot mic. We have a hot mic there, John. All right, we're back.
Huh?
What do you want to do?
I don't care if you want me up there, that's fine. Otherwise, I was just gonna keep watching the screen and audio.
I didn't know. I didn't mind.
All right.
So jump in there.
All right,
Got that done.
so how are we gonna do this? We're gonna start up.
We're gonna move the
starting
camera.
commission.
In fact, I'll watch this.
Spin it around. So it's sort of that, or flip the table over here or something.
Here,
That's
what
a
do you
good
want to do?
idea.
I'm just gonna move this up.
See these two?
That's about it, John, right there.
Yeah. All right, guys, so what we're gonna do now is we're gonna do a startup of the system. So it's wired, it's set up, and what's the first thing that we're gonna do, guys?
First thing you want to do after you power up the system is you want to run the duct linearization test. So to get to the duct linearization test on the main thermostat, because this is zone 2, you can see zone 2. So you know your zone stats are all labeled zone 2 out of the box. So you will need to go in and change that if you have zone 3, zone 4, and zone 5. But that's how you can tell the main stat from the zone controllers. So on the main stat, you go to the bottom left corner, the 3 straight lines, then you go into settings, and then zoning. Oh, sorry, wrong wrenches. So wrenches. Bottom 3 lines, service, and then down the bottom, you'll see zoning checkout. Just touch zoning checkout. Oh, test one. So it's already in duct. That's what you should see. It should say off, so you would touch the word off. Highlight that, change it to duct measurement, and then hit start test. And what that's going to do, it's going to open.
Take that off if you want.
Yeah, it pops right out. On the side. So that's now going to open each zone individually, start the fan at a low speed, and it will then learn how many CFMs it can push down each zone. And it's also going to close all the zones and see how much duct leakage you have prior to the zone dampers. So this test, you'll see on the screen, it's just going to count down from 30. It takes about maybe a minute or 2 for each zone. So the more zones you have, the longer this test is going to
A
take.
little closer.
Hang on.
That's-
Right about
yeah, that's good.
Hopefully everybody can see that.
Yep.
So all of the excitement happens right there, just watching the numbers count down, and now it's going to zone 1. So it's going to start the fan and close the bypass damper, and you should see zone 1.
Zone 2's
Zone
closing.
2 is closing, zone 1 staying open, so it's just going to learn how much air it can move down zone 1. Thanks for putting some light on that.
You're welcome. Don't forget to show the red and green lights, the pre-Christmas
Oh,
lights.
there they are on the zone panel itself. You can
And
see
the
we have a
damper
2
lights.
zone setup, or two panel setup. But you'll see the green light for zone 1 opening, red light, well, there's nothing on zone 3.
Now you notice on the side of
Bypass.
the dampers now, the red lights are on.
On the sides of the dampers for a closed damper and then open damper.
Now, if you ever see a damper that there's no light on and nothing's moving, that means we're in a mid-position range. We're not fully open or fully closed. So you'll see that when we're using either the bypass to bypass some air, or the second or third zone as a dump zone. In this case, you see what's happening here right now. Zone 1 is closing, zone 2 is opening.
It's also indicated here on the panel. You see the green light on zone 2, red light now on zone 1.
And it takes approximately a minute.
A little closer on that, John.
And now we go to the bypass.
And again, zone 1 and zone 2 are closed, and now the bypass is open. The bypass is always your last zone.
Either on panel 1 or panel 2.
And what are we doing now, guys? I'm sorry, say that
We're
again.
doing the duct
Duct measurement.
Measurement. And what is this doing? This is measuring how much air can be pushed.
down each
Down.
zone.
Okay.
It's at a very low speed. And then here on the stat, while this is going on, you can actually watch everything happen. So if you just hit the back button, and then it'll take you right to the status menu, and you hit zoning, and now it's going to tell you both zone 1 and zone 2 and your bypass, and what position those dampers are open, so you can watch them move on the thermostat.
So right now here you can see zone 1 and 2 are closed, bypass is open. We can go back to the furnace here. We can look at our CFM, our RPM, and our static pressure also on this. So right now, we are closing all 3 zones here in this case.
And now it's checking for leakage.
I'm sure you can hear it.
Oh, yeah.
You'll hear the fan picking up speed.
Oh, that sounded.
It ain't
You got-
whistling Dixie.
You got some leakage.
Well, there is a register.
Well, if you have a register up
There's
there,
that
Yeah, that's
register
up
up top at
To
for
allow
for
us-
that reason.
for that reason, so we can show that during the class.
I got you.
So right now, if we were to open that one all the way up at the top, it's gonna throw an alarm saying there's too much leakage.
Yeah, which is more than 25%.
That's correct.
That's when the alarm goes after 25.
You may get a static fault during this part of the test. You don't have to worry about it. It's going to ignore it. It expects there to be a high static in this case.
So now the test is done.
That part of the test is done.
So that's the first part of the test, right, guys?
Okay, so now we go back. I was just gonna show them how to get there again. So again, bottom left corner, the 3 straight lines, and then service, and then zoning checkout. So now the duct
So
measurement
now we
test
can
is finished.
see the percentages. It gives us the percentages for each zone.
All right, so we got
33, 33, and 32%.
Wow.
Okay, now we're gonna shift over.
touch the word duct measurement, and we change it to linearized dampers, and then hit start test.
And explain that, Brian.
So now what this is going to do, it's very similar to the duct measurement test, except it's going to stop the damper at every interval along the way. So now the system is going to know how much air it can move when that damper's, at every step of that
Seven
35
times.
steps.
Yeah, it's a 35 step. It'll stop 7 times. So if you count to 5, you'll see it'll stop at a position. So right now what we're doing is we are opening everything,
So right now,
getting everything going.
everything's wide open. Yep, everything's wide open.
So now what this is doing, Brian, if you go back to the zoning, to the checkout, no. Sorry, back to the zoning.
It won't let you. You can only do the status while it's in the test mode.
Okay, so now we're gonna see what's happening here. So now we have a damper.
All right, zone 1 just
Zone
closed
1.
slightly.
You'll see we're at 86% now. And you can see it doesn't look like it's closed much.
But it moved ever so slightly.
Back to the timing
60
screen.
seconds.
You want to go back to the timing screen?
It is though, I can see it. Yeah.
30
There it
seconds.
goes. There it
30
goes.
seconds.
So now just close a little bit more.
Position, you can see it.
71% now it's closed or open.
That's cool. That is cool.
So now, this is the timing thing. Okay, so as we're doing this, and the contractor's like, how long is this gonna take? It's going to take a while.
As long as it takes.
Okay, I've been on jobs for up to 4 or 5 hours, first of all, correcting airflow issues. First, correcting wiring issues before I can even get to the startup of this. Then once, depending on how many zones you have, you'll find that it will take longer for the zones because each duct has to linearize. Now, we're gonna get into a few more things after we get through this. But as I said, this can take time.
Now it's down to 43% open. See, it's over halfway closed at this point. Oh, we're in status.
Yeah. So go into the furnace.
No, that one right there.
Yeah.
So that shows the position and then the countdown for seconds. So once it gets to 0, it'll change the position once more. Because position 10.
It starts its countdown from
That's
30.
30 seconds. It'll do the same thing with zones 2 and the bypass.
And we can go back here and we can watch our CFM
Static.
and our static pressure as things start to change.
As they start closing the dampers, you'll see your static pressure go up.
Okay, so important thing to remember, you want to watch your static pressure.
So and as you were pointing out earlier, with the zone damper being partly open and no light being on, well, it just turned on and closed some more, but
Go some more.
that was.
And as it's its position, the light goes out.
Goes out, lights out on the damper as well. And now it's closing.
And you'll see, we are almost fully closed now.
Five more seconds of that, and then it'll go to fully closed.
Yeah.
It's much better, John.
Good.
A little shaky with the coffee.
Not enough coffee.
No.
No, so now guys, remember, if we have, okay, one of the things I did want to discuss is we can have multiple dampers, up to 5 dampers per zone. Okay, so when we're looking at a house and you say, oh, there's no way to split the ductwork up, okay, to actually have the house zone upstairs to downstairs, any of that, you can. You can actually get the round dampers and split. If you have 6 zones or 6 runs going upstairs and you have 6 runs downstairs, you say, well, that's too many dampers. Okay, that's 6. Well, what I found was if you split one of the ducts coming off with one larger damper, you can put a Y in and pick up 2 of them at the same time for that zone, which keeps you in your 5 per zone. They will, now you have to remember, all of these dampers will modulate during a test at the same rate. So as you see, we're into zone 2 now. And guys, it's important. I've had guys get impatient with this part of the test and say, ah, that's enough, and turn it off. Now,
Let the test finish.
yes.
Have to.
Yep. So when I go in and I look at it, I'm like, something's not right. We're gonna have to go through the startup again. Oh, contractor's so excited about that. So the startups are important to let it go through the entire startup.
Guys, while we're watching this go through, is there any questions you want to ask in the chat or come off mute? What are we doing?
We're on position 15, about to go to 10.
I'll be the
so-
contractor. Are we done yet?
It's gonna take another couple minutes.
I got another,
Got 3 more jobs
I
to
got
go
another
on.
call to go on.
Are you guys buying me lunch?
So, yeah, like, these tests are not quick, so you need to, plan a full day for the setup on this system.
Remember, guys, this is a very unique, expensive system. So I think that to provide professional and courteous setup of the system, I think this is part of the job. This is part of the setup. This is why this is a unique and, really nice system to set up. Once it's set up, it works flawlessly.
There's a question, how does the system calculate CFM and stack?
That's an algorithm built into the board by all the really smart engineers down at Ream. Okay, they're looking at RPM, they're looking at amp draw, they're looking at the way the system's running. And that's how it calculates your CFM, your static pressure, everything you're seeing right now. Okay,
The information was always there. We just never saw it as service techs. So the variable speed blower motors always had that information. The engineers just tapped into it and just used it to drive a zoning system and set it up through that same information.
now as techs in the field, we get to actually see this happen live on the thermostats.
Right.
So now it's on the bypass there, on zone 6, so that's your bypass there. And we have it wired up here, zone 6. It's bouncing.
Is there more questions?
Yeah. It's not grouped.
Yeah, that's fine.
Okay.
Now, guys, here at P&N Distribution, I know all the distributors aren't the same, but we've actually, Brian and I have gone over and we've actually worked out a program where here we actually go out with our contractors and we call it a field startup training, which we offer at a price for our contractors to go out. And it's kind of a one-on-one, hands-on in the field so the contractor can see exactly what to do. We've had excellent feedback from the contractors and homeowners, knowing that we're involved and that we're out there to work with we call them our better contractors, our pro contractors. We don't see two chucks in a truck out there putting zoning in. We pretty much don't allow certain contractors who we know can't understand how intricate this is, and we try to weed those out. So, we get the guys who come in and they're, I'm going to put in a 92% furnace and I want to put in that zoning you have. Well, if you're putting in 92%, you're not the guy we want. So we want to make sure that these systems are being installed and set up properly.
Right.
So if any of the DSCs listening to this, want to get a hold of me, I can go over what we're doing as a distributor, or you can get a hold of Brian and we can go over it with you.
Absolutely. We're here to help you any way we can.
It's approximately 6 hours to right, John?
It can be the fastest I've ever been on a job site. And I have to tell you, I was quite impressed with this contractor. He had not been to one of my classes yet. And he actually went out and he read the book. It was amazing. I was floored when I walked in the door. The system was wired the way it was supposed to be. He asked me some questions beforehand, but he wired it exactly the way I said. The dampers were sized. This was a brand new house. Zoning was set up with the right airflow for all 3 zones. The bypass was installed. The only thing he didn't do, which he had a fault on the thermostat, was he didn't tell the system it had a bypass at first. So it threw a fault. The only thing I had to do was power down and default the thermostat. And then I was able to pick up the bypass at that point. And the system, I believe I was there for an hour and a half. That's the shortest I've ever been on job site. Normally it's about 4 hours. I've been there as long as 6.
Where are we with this duct linearization?
Almost finished. 30 more seconds.
Now, once it does its duct linearization, what happens next? Are we done or what?
Depends on the software in this thermostat. We're going to take a look at it when it gets done. there could be an airflow setting
Right, that's what I was gonna say.
at that point.
Go to the airflow settings.
Airflow
make
settings,
sure-
and we can check the airflow we're getting through that. If it hits minimum airflow, if it doesn't hit it, what we need to do, setting our over conditioning for our other zones. And as you see there, it says done.
Get better fingers.
Zone airflow. So you'll see zone 1 here. Okay, airflow limit, 618 CFM. Lower speed, 618 CFM. Now we are running through that first.
We never talked about an asterisk next to.
No, we're gonna get to that.
We're gonna get to that?
Yeah, we'll get to that.
Other
Okay, so
Yeah,
now let's check zone
You're
2.
moving ahead.
Okay,
So
sorry.
check zone 2, so now in here, we can actually change these to unlimited. Okay, but we see we can hit 618 CFM with this zone with no issues. Okay. Speed, we're picking up speed. Lower speed right now is 958 CFM. And we just slowed back down. So now I can jump up here to zone 1. I can go to zone 2. And we're going to get set there. So basically, it's confirming airflow.
He's got room for his hands.
That's better.
So right now, Brian, if you want to back up, you'll see what's happening up here. Zone 1 is closing. Zone 2 has opened fully. Now it's doing its airflow test. It's confirming the CFM. It can move through that zone. In zone 6, you see it automatically jumps to zone 6. Because it knows the bypass is there, and we only have 2 zones. Okay, so I have my airflow set for zone 6, it's still limited. Okay, which is allowing this thing to ramp all the way up. Now, this is what I want you to see. Lower cutback. Okay. So in this case, we can see what happens when our ductwork is limited. Okay, and everything is closed right now. Go to
Can't really hear the whistling too much, but I can hear it. It's all right.
that completes the startup. Now we can go into zoning. One second. Status, zoning. Right now you can see everything is closed at this point. We're not calling for anything, either cold, actual temperature. Okay, so now if we set this to cooling, it'll show our cooling set point. Set it to heating, it'll show our heating. Set it to auto, it'll show us both set points.
Is there a screen that shows you what the CFM is for both zones? What it's set for?
Okay, so right now we're set for high airflow setting here, 443. High airflow setting there, 426. Okay, and this is where you can actually type the name in a text. You can name them upstairs, downstairs, master bedroom, other bedrooms, whatever. You can name them there. Okay, so this is where you're going to see our over conditioning. This is where you're going to be able to set over conditioning. Okay, in this case, I have it set for 1 degree. Okay, if there's an issue with the system, we also have the option of following zone 1. So if we see an issue with the zone stat or something like that, we can have everything follow zone 1 and the whole entire house will be like a one zone house again.
So can we answer that for everybody?
I was gonna, once you finish talking.
Yeah.
So we had a question come in about shielded wiring and if shielded wiring is needed for this system. No, you do not need shielded wiring.
Did we talk about the asterisk?
Yeah, straight. You're not going to see it on this one, but we'll show you. Normally, go ahead. Go to status.
Settings and then zoning. And normally right here, if there was a blinking asterisk, I'm gonna lower it down. Lower it down. There it is. So now you see a blinking asterisk. So that blinking asterisk means that this system will not be able to reach the minimum CFM requirement through that zone. Which furnace?
I believe it's 550. This is a 60,000. So I believe the minimum airflow is 550.
Okay, so the minimum airflow for this furnace is 550, but this zone can only move 415 CFM. So that blinking asterisk tells you that it will need either to use the bypass or a dump zone for zone 2 as your over conditioning area. So it needs to move more air somewhere.
So in this case, what we did, because we know our ductwork can handle it, when we go up to high, okay, we'll see that the asterisk goes away. Okay, because now it will hit the minimum airflow required. Any questions about that?
But I do have another question. I have a unit that won't go to full capacity on a zoning system. What might be the problem? If it won't go to full capacity, and only 1 or 2 zones are calling, what do you think it could be the reason why it's not going full?
So these airflow settings will also limit the capacity of the equipment. So this zone can only handle, so the second, so 426 CFM. So that can handle 1 ton. So that's what's going there. The equipment is going to modulate down or be handcuffed to only running at that capacity.
So that's why it's important to maybe choose a modulating outdoor unit or a variable speed.
2-stage, at least the
Or at least
2-stage.
a 2-stage, then that way you get the benefit of the variable outdoor unit. And then run a small zone with a very limited amount of airflow. Correct?
Yes, so you're not going to need full capacity in that zone.
Correct.
Any other questions?
I don't see anything else coming in. Do we have anything else we want to cover?
I think we've hit
The important
all the
thing,
important parts.
Okay.
Here of this.
So guys, I'm just going to ask one more time. Is there anything else that you would like us to cover regarding zoning? Either via chat or open up your mic and talk to us. At this point.
The one thing that we did want to show them was the single board, 2 board.
Oh, yeah.
So if we come over here, we'll notice our one panel here. This is our 2 board. You see they're in the same enclosure here. This is how it's shipped from EWC. All you need to do is unscrew 4 screws, move that to the top, drop the second board in below it, and you have everything in one enclosure.
Once you're done setting this up, is there a way to keep the homeowner from showing the contractor the lock? To get into all that.
We don't really have a lock.
Don't really have a lock. We do have now on the installer setting now, the old thermostat, the 601 model, you would just hit settings and then installer and it would just open up the screen. Now you have to hold your finger on the installer button. But as soon as Rheem did that and put that out there, Okay, some contractor somewhere figured it out and went online and told every homeowner out there how to do it.
It's the joy of-
So the joy of the internet.
Yeah.
Okay, so,
It's-
yeah, I mean, I
can
think
see
this
that.
went very well today. A lot of information to pick up on, but, you know, the information's out there for you. I think Lou recorded this.
Yeah, so I recorded this, and my goal is, here, let me just kind of get in the camera here. So my goal is, guys, that once this is recorded, I get it back to the office, that I forwarded the recorded meeting to everybody who signed up, or everybody that was on the meeting, and then you guys could disseminate it to whomever. So, again, this is my first recorded meeting that I'll be sending out, so apologize for any flubs or any, whatever, but I think it went pretty
Went
good
pretty
for our
smooth.
first time, guys. So, I'm standing between
Right.
Do you need
tall
a-
guys.
do you need a
Get
step
up
ladder?
on the- get up on the-
Hey, get up on there, really. Get up there, real quick.
All right, guys, thank you.
Yeah, thank you very much for coming in here.
Reach out to myself or John. You know how to get a hold of us.
Yeah, we're in the email chain, so